55 रोल नंबर एडमिट कर दिया देख और कर दो एडमिट और
व्हाइट बोर्ड चेंज करें बस है ब्लैक लेवल।
अब आ रहे हैं मेरे से
ये रख लेते हैं ऊपर बाजू में।
हाँ, ये चल
हाँ ये रखा है।
रहने सब ये ना कोई बात नहीं।
लैपटॉप
अच्छा
यही रखे भाई वो मैं कर रही
सर
ग्लास से आगे।
हेलो गुड मॉर्निंग एवरीवन गुड मॉर्निंग
Good morning, sir.
राइट माय वॉइस इज क्लियर
Yes, sir.
यस सर।
okay so we'll discuss today's class with the model papers we have already completed the other autonomous colleges question paper I've just now I have right uploaded in the WhatsApp group you have seen uh, Methodist and Vardhaman College papers which has been appeared in the final examination right in March 2023. So everybody is familiar with the question papers which have been uploaded to you. Please, you can just, for your reference purpose, you please see that questions and we'll discuss different types of questions which has been asked in the autonomous colleges question paper. Right? You just saw it. Now, see here, the first question that is given to you, write the limitations of free electron theory. Right? So you already know that we have already discussed this. That is free electron theory is nothing but we'll call Drude and Lorentz theory. Right? Drude and Lorentz theory. This is actually also known as right free electron theory. Free electron theory. Drude and Lorentz or free electron theory. Now, so what is the different limitations, or we can say disadvantages, which has been asked in the examination? So, if you can write 2 to 3 disadvantages, that will be enough for you to fetch 2 marks. Right? Likewise, classify intrinsic and see here 1, 2, and 3 disadvantages. If you can write it, so that will fetch you the 2 marks. So, what are the disadvantages? What you have to see, you please like the disadvantages of free electron theory. Anybody can tell me the disadvantage of free electron theory if you can remember it. What are the disadvantages? Or we can say failures also. Now, see here, first one is what? Why the solids are divided into all the solids. Why some solids are conductors, right? Some solids are conductors, and why some solids are insulators. See, solids are the substances which will also act as the conductors, and the same solids, why they are acting as a insulator. That is a disadvantage of the free electron theory. And also the same solid will act as a semiconductor. This is one disadvantage. This is one disadvantage which has been it should be written in the disadvantages. Now, you can just see that the other disadvantages that we you have to write in the examination is right. Why the properties of solids which are determine the internal structure. Why some solids, see, why some solids, right? Properties of the solids, right? Depends upon the internal structure. Properties depends upon the properties, depends upon the internal structure. Why it is happening? That depending upon the internal structure, why the solids properties are changing, right? Internal structure. So if you can just write this important disadvantages, structure, right? These are 2 marks question which will be asked you several times. It has been asked in the examination. Now, another, see, another disadvantage, that is it. For if it is possible for you to, right? Electrical conductivity of semiconductor was not explained clearly in the free electron theory. Electrical conductivity. See here, electrical conductivity has not been explained in the free electron theory. Electrical conductivity of semiconductor has not been explained, right? Of semiconductor. These are the failures, or you can say the disadvantages of the Root and Lorentz theory or free electron theory, or we can say that it is a classical electron. See, classical theory. In the examination, the question will be asked in these three synonyms, right? Classical, classical. So one is CLA, SCI, classical theory. Instead of free electron theory, directly he can just give you classical theory. So either he will ask you regarding the uh, disadvantages of the Drude and Lorentz or free electron theory or classical free electron or classical theory. So the question will be different. You will have a answer will be same for these three sentences that they will be giving in the examination. Now we can just see that classify intrinsic and extrinsic semiconductor. This we just started with the Methodist model paper, and we are just comparing this Methodist model paper with the other college, that is Vardhaman also. We are just comparing the questions and we'll try to write. So if you can write this three, even if you write three also, you'll get 2 marks very easily. Understood, everybody? Now, yes, any doubt that you are having in the root and for free electron theory? Anything? See, I am just reading the questions. Wherever you find that difficulty, that this question we don't know, sir, please explain us. So definitely, I will go in detail of that particular question. Yes, sir. Students, are you able to hear me very clearly?
Yes,
Yes,
sir.
sir.
All right. So please see the Methodist model paper and just tell me the 2 marks question such that we can go for the long answer question. See, first question we just discussed the answers also. Now the B bit classify of intrinsic semiconductor, you can just write whatever you have written in the intermediate level, and also what is there in the notes. That same thing you can write for the intrinsic and extrinsic semiconductor. So please tell me that if you have any issue with this intrinsic and extrinsic semiconductor, or we'll move the other question. Intrinsic is a pure semiconductor, right? And extrinsic is a impure semiconductor, which is again classified into P-type and N-type. So if you can just write the basic 3 to 4 differences, that will be enough for you to fetch the 2 marks, right? So any problem with the intrinsic and extrinsic semiconductor, students? Please tell me. No? We'll go further.
No problem, sir.
Right. C. You just see the C with. What are the applications of ferro? Yes, you can write C. Definitely. Fazil, you can write the classwork answer of semiconductor. As it is, you can write in the examination also. There is no issue. Okay.
Okay,
Mr.
thank you,
Fazil?
sir.
Right. Now,
Okay, thank you, sir.
what are the applications? C bit, it is given applications of ferroelectric materials. So applications are already there. If you can write applications, 2 to 3 applications, that will be enough. See, applications of ferroelectric material. So ferroelectric materials are those materials which will exhibit spontaneous polarization, right? You already know, we'll call that as ferroelectric materials. So these materials are having various advantages. So can anybody tell me what are the advantages of ferroelectric material? Any doubt in this particular question? Right, they are used as for keeping the
Oscillators and filters.
oscillators and filters, right? So this question has been asked in the 2 marks question, right? Oscillators and filters and so on. There are different applications, right? If you can just write 3 to 4 applications, that will be enough. Now, write the differences between soft and hard magnetic materials. You have already written this, right? Okay. Soft and hard magnetic material, depending upon we are talking about which materials? The magnetic materials. See, depending upon the hysteresis curve, the materials have been classified into soft and hard magnetic materials. So you already learned that hysteresis, right? If the width of the hysteresis curve, so you can see this is, I'm talking about d bit. So these particular material, now this is H, and on the x-axis you'll find H, and on the y-axis you'll find B. Now these are nothing but, if you draw that hysteresis curve, you will fetch 1 marks, half marks, right? Soft magnetic material. So in the same manner, magnetic material. In the same manner, in the other classify means you have to write points, right? In the other one, if you can just the width, see, this is the width of the hysteresis curve. So in this also, you can see that the width here is wider, and here you'll find the width is, when compared with this hard magnetic material, the width of the hysteresis curve is, right, less. So these are what? Hard materials, hard magnetic materials. Clear, everybody? Now, this is which question? D bit. In the same manner, E bit, you can just see what is persistence current, critical current. We have already discussed persistent current, the current which is continuously flowing without any application of external voltage is said to be persistent current. And critical current definition, the critical current is the current wherein the superconductivity will lose its conductivity, will lose its property of superconductor, and when the current is, right, is greater than the value at which the particular material exhibit the superconductivity. We'll call that as critical current. So understood, everybody, about the persistence? And persistence means, see, what is the definition in the English? So when we just write the synonym of persistence, persistence is continuously exhibiting some property. So in the same manner, so what is continuously? It is exhibiting property. It is exhibiting a flow of current continuously with some 100 years or more than 100 years, right? So we'll just take 100 years. So continuously the current is flowing for so many years. We'll call that as persistence current. Now see here, F bit is given a de Broglie hypothesis of matter waves. This you have already studied in your lower classes, intermediate also. We have already discussed lambda is equal to H by mv. So some matter waves, the concept, explain de Broglie concept of matter waves. So some particles will exhibit dual character. We already know, sir. So it is exhibiting particle nature, and also the same same material is exhibiting the wave character. So we'll call that as dual character of the matter. We'll call this as dual character, and these dual character wavelength can be found out by means of this lambda is equal to H by mv. Right, everybody? Now this is your F bit is completed. Then we'll go for the G1. You can just see G bit, what it is given, stimulated emission with the diagram. Right? G, everybody can see, right? I'm directly writing that stimulated emission. The stimulated emission means what type of diagram that you have to draw. See, I'm drawing, this is a excited state, and this is your ground state. This is excited state, and we already know that electron is there in the excited state. So now from here, when the electron is coming back to the ground state in the air, so one photon which is released from the external source So from the external source, one more photon will be released. Now we'll call this as CL. One more photon. This is at h nu and this is h nu. And we'll call such phenomena wherein we require the one external source while the electron is coming from the excited state to the ground state. In between that, the amount of energy is released, right? So we'll call this as which type of emission? Stimulated emission, right? If you can just draw this diagram and write the sentences, what I told you now, so that will fetch you. The diagram will, if you just draw this type of diagram, you will get 1 marks, and the theoretical sentence, whatever you are going to write, and that will add up with another 1 mark, and which will be 2 marks. Understood, everybody? Now, H1 is the problem, right? See, H1 is the problem, the refractive index of the core. So you already know refractive index of the core is represented with the which symbol? N1. It is given, right? 1.45, and cladding is given as N2, nothing but 1.43. Now, in the examination, he's asking you numerical aperture. What is a numerical aperture? You already know what is the formula of numerical aperture? N1 square minus N2 square, right? And also, we are having a basic formula. Na is equal to sine theta A. So now we know what is Na with respect to refractive indices, right? We have written N1 and N2. So from here, you can also find out the acceptance angle by sine theta, right? Theta is equal to sine inverse of Na. So the only what you have to do, you have to just simplify this. N1, what is given N1? 1.45 whole square, right? Whole square minus 1.43 whole square. So when you can see, you can take the scientific calculator with you, right? Understood, everybody? Now this is what, yeah, 0.24. You get how much? You got 0.24. You got 0.24. So this value is what? 0.24. Let us, Saima got this value 0.24, right? And this is what you have to write. Now this is sine theta A. Theta A is equal to sine inverse of Na. So Na, what is the value we got? 0.24. So if you have scientific calculator, please tell me what is sine inverse of 0.24. Anybody? So you have to write this. See, if you just do this up to this level to do the problem, you will get 1 marks. Clear, everybody? And if you go for this theta A, so what is the answer, Saima? Can anybody tell me? It has come to be how much? 13.886, right? After point, how many digits we have to take? 3 digits. So theta A is equal to 13.886. Now this is the answer that everybody should get. Now, so this will fetch you how many marks? 1 more marks if you go for the acceptance angle. Clear, everybody? Right, 13.8, good. Good, Fazil. The same thing, right? We are just writing that points after point 3 digits, right? The examination also, you need to write after points 3 digits. Whenever you are doing any engineering problem, so you have to make a note that you have to write after point 3 digits. So this will fetch you how many marks? 1 mark. And this will fetch you another 1. So how many? 2 marks question. Clear, everybody? I think it is very clear to you. If you have any doubt, I'm just stopping here for a moment, such that everybody understood this law H. Yeah, H. Short answer. Now in this particular question paper of method is I is also there, right? I, what is applications? Any 4 applications of solar cell. So you can write see here, always you have to remember that whenever you are writing some applications, you have to write at least 4, right? At least 4. So each carries how many marks? Half. Clear, everybody? This is a solar cell application. So you can write that where the solar cell is used as the conversion of what energy? Sunlight. You can say it works on the principle of, you already know, light energy is converted into electrical energy. So applications, we can use this solar cell for converting the light energy into electrical energy. Clear, everybody? This is what you have to do. This is the first application, right? Like this, you have to write how many applications? 2, 3, 4, and so on, right? So this, I think that you not have any problem. You just you have to write J. What is given? Explain the significance of surface to volume ratio in a nanoscale. So the surface to volume ratio, you have to draw the figure of the cube, and that figure of the cube should be divided equally, and then you have to calculate the area of that particular face. So that is called surface to volume ratio in the nanomaterial. So please see it. Whatever the notes I have given you, if you have any doubt, you please let me know for this surface to volume ratio, which is given in the question paper. Now, see, we'll go for the yes, anybody is having any doubt? We have just discussed how many questions? 10 questions of 2 marks. Now we are just moving towards the long answer question, right? Anybody, please, I'm giving some time that if you have not understood anything, please let me know. Yes. Yes, anybody, please speak up. My voice is clear to you, audible. Say yes. Yes, yes, please.
Yes, sir.
Right, only one. Right. So now, see here, what is given? You are seeing the question paper, right, simultaneously? Whatever I have been shared to you.
Yes, sir.
Fine, see here. So in the part B method is we are going for the long answer questions. What it is written, explain the very important. See, several times it has been asked in various examination. You can just compare this long answer with the Vardhaman College also, depending upon our what you can say syllabus, right? So first question is given what? Chronic and Penny model. See, explain the chronic Penny model based on the basis of band theory. So chronic and Penny model is actually based on the band theory of, or it has been evolved by means of band theory of the solids, right? So chronic Penny model means how many postulates that you have to write? Whatever we have written in the notes, same thing you can just rewrite it, right? What we have written, the motion of the electron. See the motion of the solid, right? What we have written? What we have written, see, motion of the electron is characterized by, or motion of the solid has been characterized into valence band and conduction band, right? The same thing we have written. See, motion of the electron is characterized by conduction band and valence band. This is the first postulate that you have to write. Conduction band, and with the diagram, right? Schematic diagram, that whatever we have drawn in the notes, same thing you can just write it down here also. A valence band. Right? We are not having that much time that we have to. I am not drawing that diagram. Right? It will again unnecessary waste of time, right? So the first postulate with the P and O, right? Definitely fuzzy. When you just plot the graph, plot the semantic diagram, it should be, see, I will just semantically, I will make you again draw this diagram. See, this is what semantical representation, right? So here we have already, so it will be not very clear, but semantically I'm trying to draw that diagram. Okay. So what is there x-axis? You already know this is what on the x-axis we have taken alpha A, and on the y-axis we have taken P sin alpha A by alpha A plus cos alpha A. Understood, everybody? This is what we have drawn, right? Clear? This is the
Yes,
x-axis,
sir.
y-axis,
Yes,
right?
sir.
And we have just drawn that bands also, right? So I'm just not drawing that one. So for right now, this is the first postulate. The motion of the electron is characterized with the conduction band and the valence. Now, see here, the second one. So as the value of alpha A, you have to write the same thing what we have written in the notes, right? As the value of alpha A increases, the width of the we have written, see, everybody knows, right? So width of, I'm just, see, I'm again writing for only 2 points such that you should be very clear that whatever we have written in the notes, same thing you can reproduce in the examination paper also, right? So as the alpha A values increases, width of the conduction band increases. I'm just writing that short form conduction band, and the width of the forbidden band. Here, see here, this is actually instead of this, what we have tried? Forbidden. Forbidden. The same thing we have to write here. Width of the forbidden band decreases. Forbidden band decreases. See, this is already we have written in the notes also. I'm just recalling it. Band decreases. Clear, everybody? Right? Like this, you have to draw the diagram and write all the theoretical points and geometrical value. It will fetch you how many marks? 6 marks question. This is what? 6 marks question. So I think that you will learn. Yes, please speak up. Yes, anybody? Anybody is having any doubt? You please tell me. No? Proceeding, I'm proceeding further. Right? Okay. Now see here.
Yes, sir.
Right. Now see here. What is the question? It is given in the second 2B bit of the method is 2A1 is chronic penny model. You see, what is even? Explain Hall effect. We have already done this, see, right? We have already done this in our last class. If you are not clear, see, whatever I'm writing, it is clear to you. My
Yes,
writing
sir.
part.
It's clear.
Fine.
Yes, sir.
Right. Now, explain Hall effect. We have already see the same thing you have to write in the examination. See, drawing that diagram, whatever we have drawn in the previous class, the same thing you have to draw that and write that derivation also. So here we have these are what? Positive charges, and here we are having the movement of the electron, right? Which is indicated with the arrow, this arrow, left hand side arrow. Now this is what? These are negative charges, right? And this is we have already gone for thickness, and this is the value of B, right? And this is your which axis? Z axis, and this is your X and Y axis. So I think that you will be very, very clear with it. Y axis. We have already the same thing we have learned in the previous class. And we already know that the force which is acting on the magnetic field is BEV, and the force which is acting due to this electric field is E. And this is cancelling out. And what is remaining? BV is equal to, and what we have written instead of E, we have written H, E suffix H. So V is equal to EH. See, this we have already done, right? So I'm just recalling it, what we have completed. Let us consider this is your equation number 1. Now the same thing, see, we already know that since I is this is a semiconductor within the shape of a cube. So when a specimen or semiconductor or a metal is placed in a transverse magnetic field, this is magnetic field, so which is carrying current I. So a voltage is generated. That voltage is said to be Hall voltage. So when this I, which is acting, when is coming out from the semiconductor or a specimen, what is happening? Now it is becoming Jx. So Jx is current density, which is given as NEV. So V already you know. What is V? Jx by Ne. Again, let us consider this is equation number 2. We have equated that. And what we obtained? See here, EH by, see what you have to write? Comparing equation 1 and 2. Comparing equation 1 and 2, what you will obtain? EH, can I write like this, right? EH by B is equal to JX by NE. So what the scientist says, what the Hall says here, so he says that I can just replace this 1 by NE as RH. He just replaced that. RH is nothing but 1 by, instead of writing 1 by NE in our equation, right? This is equation. Let us consider, I'm talking about, we just mark it as equation number 3. So RH is equal to 1 by N. So what the scientist says that EHY, yeah, in 10 minutes our class will be completed. So whatever the doubts you are having, you please let me know. Okay. So now it is very clear to you. We just discussed, right? So JX, see here, JX into directly what I can write 1 by N is what?
RH.
RH. So instead we have already done this RH. Yeah, problem on the, see here, write the problem. Yeah, you may get the problem of Hall effect also. Definitely. See, right, like this, see. So we have just, see, we in the examination, if we ask you explain Hall effect, until this you have to complete this, right? RH is equal to B into JX, B into JX by EH. Clear, everybody? So RH value we have just obtained as B into JX by EH. This is what the explanation of Hall effect. So how many marks it will fetch you? Right? How many marks? It will fetch
6.
you 4 marks. Already I told you, right? 4 marks for the explanation of Hall effect, and 2 marks you will get for how many applications you have to write? I said to you 4 applications. See, so total how many marks? 6 marks. So 2 marks for the 4 applications that you have to write. You can just see that method is question paper also. The same syllabus. We are following the same syllabus. So 4 applications of Hall effect. So if you can write that, that will be more than enough. See, directly. See, whatever I've written here, just theoretical sentences I have not written. Unnecessary. This is theoretical sentences you are already having. You can just write from the notes also, which has been shared to you. And from the, see, the theoretical sentence, I have just gone for some mathematical values. So this will have fetch you 6 marks. So right. So in the next, we'll move to the next one. Anybody is having any doubt in this? Anybody?
No,
If you
sir.
are not clear, or if you're having any problem, you please let me know. Okay. Now, just see this. Now, we'll go for the third one, third A bit. Third one, A bit. And you can just see that Vardhaman also. So in the Vardhaman College paper, see, quantum computing, we are not dealing. You can just see I'm talking about what? 2A. Set up the Schrodinger time independent wave equation for matters. And in the same, that is how many marks it has been awarded? 5 marks. So here in our case, we'll be getting how many marks? 6 marks. 2B. See, we are just dealing with the 2A on 2A, 2B. 2A or 2B of Methodist and 2A, 2B of Vardhaman College. We are just comparing it. In that 2A, what is given? Chronic-Penny model is given and Hall effect is given. In 2A of Vardhaman College, same 2A value here, we are having Schrodinger time independent equation. So if you can just, if you have any doubt in this Schrodinger time independent equation, please let me know such that I can again explain you that Schrodinger time independent. If you not, we can move forward. Yes, anybody is having any doubt? In Schrodinger time
No, sir.
independent, right? So 2A, yes. So 2A is Schrodinger time independent wave equation, and 2B is given as, you can just see the Vardhaman College paper. What is the physical significance of wave function? So the physical significance of wave function gives it limitation. So here we are just limiting ourselves to physical significance of wave function. In the examination, he will not ask you about its limitation. That is not in our purview of the content which is there in our syllabus. So in our syllabus, only the physical significance of wave function is enough. That will be given in the short answer. Probably, mostly it has been given in the short answer questions, right? So that is the difference between our college content and the Vardhaman College content. Now we go for the third A bit. What is the third A bit? Various types of polarization. See here, types of polarization. We can just see types of polarization. Types of polarization. So what you have to write types of polarization? So in the question is asked to you, you please, everybody, please see this question. What is that question given to you? See, third one, explain various types of polarization that occur in dielectric materials. So types of polarization which is occurring in the dielectric material is what? You already know. What is that first one? Anybody? Ionic? Second,
Electronic.
Electronic. Third one is what?
Orientation.
So you have to write the definition with the example. What you have to write? Definition of the ionic with the example. One example or two example. So this is the method that you have to apply for the writing the answers, right? Ionic, same thing applied for the definition and example. Definition. Next one. Orientation. Last one is what? What is the last one after orientation?
Space charge.
Very good. Very good. Space charge polarization. Right. So how many polarization that you have to write in the examination? 4. Same here. The procedure method is same. You have to write the definition with example. Here, fourth one also, space charge polarization. Space charge polarization. So how many? 4 definition with the examples, right? And see, nothing is given in here. Only explain various types of polarization that occur in the material. So each, how many marks it has been covered? How many? How many marks? 4. But the total marks is given how many? 6 marks. So how they will divide this is into 6 marks. So if you write all these things, you definitely they will give you for definition. See here, this is for definition. He will give you half mark, half mark. Right? If you write some explanation, then again it will be added to. So mostly, right, 1.5 mark, or sometimes he will give you. See how many marks is there? 4 is there, right? Directly definition 1 mark, definition, so 3, 4, and or examples, right? All the examples if you can write. So it will, for example, he will give you half mark with diagram. So this will include how many? 2 marks. So how many marks? 6 marks. Clear, everybody? Clear? Example,
Yes, sir.
example, half mark, and diagram, which is including diagram. Here definition will fetch you each definition of the polarization which we are discussing, that will fetch you 1 mark. So that is completely how many marks? 6 marks. This is 3A. When you go for 3B, V's domain theory of measure. See, V's domain theory means this is completely different. V's domain theory is different from hysteresis curve. Always remember, V's domain theory. Right. V's domain theory is different from the hysteresis. We are not discussing here the hysteresis curve. Clear, everybody? Domain theory here, something. What is that one? V's domain theory of magnetism with the help of the diagram. Means you have to draw this magnetic domain diagrams like this. And the theoretical statements and the mathematical one. So this is what a domain like this. You need to go and write the theoretical sentences and understand. That is your V's domain theory of ferromagnetic material, and which will give you how many marks? 6 marks for the diagram and magnetic domain definition. You have to first write the definition, and this diagram will fetch you how many marks? 1 mark. And the theoretical and mathematical steps that you will do, that will give you how many marks? 5 marks. So if you have any problem with this domain theory, please let me know. That will end our second question. Yes, anybody? Right? You can please, again, you can compare it, and if you have any doubt, I will just answer it. And if it is possible, again, we'll conduct the class for you, online class, that wherever the topics that you are having difficulty, please let me. After your practical examination, if possible, definitely will again we'll have the online class. Yes, everybody. Yes, speak up. I'm audible.
Yes, sir.
So please let me know after you just compare our model paper and the Vardhaman and the Methodist question paper. And if you have any topic problem with any topic, you please let me. Clear? So again, we'll meet in the next class, right? It's less than, so I'm just right logging out, everybody. Thank you very much.
Thank you.
Thank you.
Right.
PDF भी डाउनलोड हो गया मैंने उसमें फंसा दिया।